The responses we have seen in people being very, very eager to learn AI is amazing. And we will also have cutting edge AI today. So you will see some examples of AI that is being used by the world leading experts. You will see in the real way it's being used. We will talk about some use cases as well. Now for why we're all here. And that, of course, is the AI face detection, right? And this is a highly advanced use case, and we've intentionally picked something which not only sounds hard, but seemingly is amongst the hardest things possible. And the reason we have chosen that is to show you that by using the work of other researchers, other applicants that we can find on the internet, all these seemingly hard things become a lot easier, right? And that can be done through two main channels, that reutilization of work. One is using libraries, which are pre-supplied or can be downloaded to augment Python. The other way is simply by Googling and finding Git repositories that can help you, or finding research papers or other things that can greatly improve how easy it is to implement something and put a business case around it. What we're going to do today, and of course you've all seen this image that around, is exactly this here. So we're going to have some 68 points that are tracking what's happening in the face, and obviously a video can say more than 1,000 words. So let's see this in real time. I'm going to start it here from the command line. This looks a bit more complicated. Later, don't worry, we will go to the normal programming interface that you most likely are more familiar with. I'm doing it from the command line now so that we can see in real time from the camera feed. And we'll also use the camera feed later. And now I'm moving around already. You see clearly this is able to track my facial landmarks very nicely. We can see here is the outer part of the face, and then we also have the eyebrows, the eyes themselves, we have the nose and also the mouth, and we can see, okay, the mouth is also able to track when it's opening and closing. It is definitely able to see here a difference in the point location. So that interactivity, you're really opening up some interactivity here with the user, is crucial, and it opens up so many different use cases. And a very obvious application of this is in gamifications and literally building games. One of the people I know that is using this technology has founded a startup around just doing use cases like this. He has developed an application, and it's a simple game application where burgers are falling from the top of the screen. And the user then has to try and eat these burgers interactively with his or her mouth. And with that simple application of eating burgers that are falling from the screen, this person has made millions. So there's tens of millions of downloads in Southeast Asia alone. The app is going viral worldwide. And it's, if you think about it, it's doing nothing else than detecting these 68 landmark points in the face and putting a nice user interface on top of it. And when you will see later how easy it actually is to get these 68 points, you realize what an amazing opportunity we have in front of us here. Another application, and this is very common, is very likely you have interacted with this, maybe even today already, is facial identity verification. So most facial login technology actually also uses these 68 points here. It turns out that some of these points, how they are located to each other, is incredibly unique. So for example, this point on the nose versus this point here on the eye tends to be fairly stationary. It is now possible when you have these 68 points, and that's what you will be able to do after this workshop, to put another model on it and say, okay, I'm measuring the locations of these against each other, and because I've got 68 points, that becomes extremely unique. This is like a human fingerprint. It is like an iris scan. In fact, we have tried this out, and in a test setting with real images, so these are not controlled images, not lab images, an AI that we have built has been able to detect if a user is really the user that he or she claims to be, with 99, and there's a 6 nines followed by a 4% accuracy. This is extremely unusually high. Let me emphasize, you can't always expect this from AI to be that exact. And for comparison, a human trying to identify the identity of a user just by one single facial image tends to have an accuracy around 94.27%. So this is extraordinary, and that's why this is being used in security applications. Another closely related component, of course, is liveliness check. And that often goes hand in hand with the facial login capabilities. So as part of the liveliness check, that is really to prevent the user from using a static image and fooling their way in. So if I show a static image, I simply ask the user in the interface, could you rotate your head around a little bit? Could you maybe open your mouth? Could you open your eyes? And only if it's a real video feed, the user is able to do that. So that together with the login makes for a very safe login application that you can build with this. Of course, the big blockbusters in the Pro world that you already know that use similar techniques are all the face-based things. And certainly in the medical sector, we are amongst the leading players worldwide, not only in the insurance. So we have already our well-known BMI age gender prediction. It's well possible nowadays to predict even your heart's pulse just by looking at the face. That is possible because the light being reflected by blood cells looks different than the light being reflected by flesh cells. So we can filter the images coming from the user's camera and see how the blood is pulsing through the face. But that pulsing alone is very hard to interpret. So you need to know what areas of the face are you looking at to really make sense of this. And that's true for all these medical applications typically. And it can go all the way to even detecting skin cancer just by looking at someone and telling in that specific area of your face or of your skin, you're having a skin cancer which needs checking, actually, medical checking. So that's very useful for us to be able to track down specific areas inside the user's face for controlling the location where these algorithms look at. Before we go in and we start getting the 68 landmark points, we're going to look at two crucial foundation components that we need. And one of them is we need to understand how does a computer really use an image. And what we will realize as part of this journey is actually working with an image is very similar to working with an Excel spreadsheet that has only 3 sheets inside. First of all, let's look at a fairly easy to manage image. So this is a black and white image of a Chinese handwritten character. And this is how the computer sees it. Now, these numbers are a little bit small. Excuse that, please. But what it's really doing is there's a range of numbers here. So this is like an Excel spreadsheet. So it's like a pandas data frame or even a NumPy array. And these numbers, they essentially have a value of 0 here. And let's look at that area in the picture. And of course, yeah, 0 just means black for black and white pictures. Now, as we go into the middle, we've got numbers that get higher. And obviously, the higher they get, the more white it is. So in a black and white picture, we only have 2 dimensions. One is horizontal, one is vertical. And each of these cells tells me one single pixel. What is the white color saturation? If we want to augment that to look at color images, there's one important thing which every painter can tell you. If you know the saturation of 3 colors, so if you know how much red, blue, and green you're using, you can create every other color that exists. And that red, green, blue coding, that's being used literally everywhere. So your TV is using it, almost every device is using that standard. So what we need to know now is not only how much white versus black there is, but we need to know how much red is there, how much green is there, and how much blue is there. So we have essentially 3 colors for 3 values for every single pixel inside the image. What we could do is we could have a tuple of these 3 numbers in each of the cells. Then we could stay on that nice 2-dimensional object here. That would be a bit uneasy to handle, however, if you think about it, that would not be nice to handle. But what we had already in that case is we can say, okay, if the value 255 in the first, then that we might use for the red color. So if I have 255, 0, 0, then that would be pure red. Conversely, if the middle value is fully saturated, I have a pure green. And for the last value, I might have a true full blue. But because we don't want to have that tuple, the trick to get out of this is to say, we're just adding 1 dimension to our array. So where before we had basically a single Excel spreadsheet with numbers here, now we're just having an Excel file with 3 sheets right next to each other. And each one of these is just indicating one of the colors. So the very first pixel up here in the corner has a saturation of 14 blue, 15 green, and 8 red in this example. And then I just go along. So we expect every single image that we're reading in Python to have 3 dimensions. And the last dimension should have exactly 3 different locations because we got 3 of these tables that we want to access. Let's look at a real example. So we're going to load these libraries. And I know some of you really struggled, especially with the dlib library. And let me emphasize, this is one of the very hardest libraries to install. You have most likely noticed something like Pandas is easier to install. And that's, again, we have picked a harder use case than typical because we want to demonstrate that even the hardest things, when you see them later in the code, they tend to become easier than you expect. For the more standard cases, you don't even need a library like dlib. This is very specific to the facial identification. So don't worry if you struggle with it. If you were successful installing, great. You will be able to follow all the coding examples that we showed today, and you will be able to do the full facial recognition in real time as part of this workshop. I'm going to load an image now, and conveniently the library CV2, which is simply computer vision library, has a pre-built function that's imread, and that's only there for reading images essentially. Let's load the local image pg.pic, and because I'm not giving it an image path, it's going to look in the local folder. Let's have a look at the folder here on my desktop. And indeed, there is an image here, pgpic, which looks like this. So it's not a very big pixeled image. If we zoom in, yeah, because it hasn't got a big dimension, it's a slightly pixeled, and it's got colors, so we expect it to have 3 dimensions. Let's have a look at how this image object looks like. And that should be reassuring to you now if you're a little bit used to data handling in Python, because that is a very standard data format actually, right? When I, for the very first time, was reading an image file, I was actually surprised to how similar this is to other data I had worked with before. So let's have a closer look first at the dimensions, and then later we'll also see what kind of an object it is. And when we look at the dimensions with the shape here, we see that we have 310 pixels times 309 pixels. And indeed, there's a third dimension for the color, and it just has 3 colors. So the dimensionality here, and we see that also there's 3 brackets. Of course, that must mean there are 3 dimensions. The dimensionality here is exactly what we predicted before. So that is how a color image is being used. And the way you can change this is very, very same to everything else in terms of data formats. So that's very, very similar to other data formats. And if you have been able to do some Excel jobs or some other jobs in Python already, you will be surprised how quickly you are able to master all the image use cases due to that similarity. Let's go into the second foundational learning, and that's now state of the art. We're looking at deep learning, and we're looking at deep learning in only 3 minutes. The reason we're able to do this again is because we emphasize, don't be ashamed to go and Google and go and reuse what's out there already. There is fairly little glory in reinventing the wheel if you already have a Ferrari that you can buy in a store. To understand deep learning, let's think a bit first about how do we as humans actually learn, right? So for example, this kid here, why does he know this is a dog? Well, the key reason he knows that is because his parents have told him before, oh, look over there, there's a dog. There's a dog walking. Here's another dog, can you see it? And there's a cat. So over time, from his parents telling him about dogs, he gets a general understanding of what the features of a dog are. And then when he encounters a dog he has not seen before, he's able to use these experience before where he was told this is a dog to put that dog into a bucket that says essentially this is a dog. And the great thing is it works the same way for an AI. So when we have a deep learning model like here, then all we need to do is we give it some, we call it pre-labeled images. So these are images where we tell it, this is an image of a dog, this is an image of a cat, etc., etc. And what I want the model really to do is to do the same thing like the baby. When suddenly it sees a new image of a dog that it hasn't seen before, it should be able to say, I think the most likely outcome for this is that it was a dog. And I'm intentionally using the I think in front because there's never going to be 100% certainty. And that's the big difference between AI and some other discipline like engineering, that we have to get comfortable with the fact that we have strong stochastic influences. So even the best model will always have a chance of thinking this might be a cat and not a dog. That error chance is always there. We just have to get comfortable with it. And there are great ways of doing this. So for example, you can use things like Shapley values. You can use predictions of the probability to quantify how certain the model is in specific cases, etc., etc. But you must be aware that this uncertainty is something that you have to work with and have to be comfortable with. An example for a computer vision application, and as real in the proof, we'll see that very soon, is Chinese character recognition. So these deep learning models here are essentially built to emulate a specific kind of human synapse. So human synapses are, amongst others, the cells that we use in our brain, essentially to think. And what they're doing is they have this tiny window here on the image. And that window starts over here, and it moves pixel by pixel over the entire image, like a scanner. Whoop, whoop, whoop. It moves over the entire image. And that first layer here is doing a specific operation. So maybe that first layer says, I take the sum of all the pixel values here, the sum of all how much white there is, essentially. Then maybe the second thing here does a different operation. So that could be saying, I'm taking the maximum of all the pixels. So then that would say the brightest point only counts for that second one. The third one might do yet another operation. So we can do many different operations, and they all move along the entire picture using this summary window. And because we use this summary window, this gets a little bit smaller than the original image. So over time, this shrinks and it gets smaller, but because we have more and more operations, so even if here I have only 2 operations running in parallel in the second layer, because here I already had 4 different operations, suddenly I have 8. So what typically happens in such a model is it gets wider, but smaller at the same time. And then at the very end, we've got one big, huge summarization, and that essentially pushes it down and says, these are the probabilities that this is a specific image. And I think the most likely kind of image this is this kind of character here, which of course is what we wanted to have, right? As promised, this is a real use case. This is a real claims form that was released for testing. And we can see here in the diagnosis field, this is the character we tried to detect before. So you can see these use cases that we're teaching you today, the underlying techniques are extremely versatile. They are so flexible that essentially everything we can do with our own eyes, we can now try and work on it with AI. And because they're so versatile, So here we also see the accuracies for this. So these are real values, and we see many of these are already detected 100% correct. If you looked at these percentages just some 5, maybe 8 years ago, it would be a lot farther from the 100% on all of them. So this is also a discipline that has made huge steps forward. And I'm sure if we would try a novel state-of-the-art technique from now, because this is maybe 2 years, 3 years old, if we would try it again with the newest technology now, and we simply take the technology from the internet, we don't reinvent it, then all of these probabilities will look extremely higher again. And that's the great thing here as well, that we can really rely on the broader research and the broader community to help us. Now, because these models are so versatile, I can also do another thing. Instead of saying just tell me one single thing, like for example, what kind of character it is, I could also tell it, actually, tell me 68 different things. And these 68 different things are all the landmarks a user has in his or her face. And that's exactly what we're going to do next. So let's look at it. And this is the magic why it's going to be very easy. So what I've just loaded here in these lines of code, and it's not that many lines actually. So the real heavy lifting happens here where we load the detector. And some of you might think this almost amounts like cheating. And you're right, because this is code we just literally found on the internet. And it's that easy. And that's really how AI work gets done. And that's why we're telling you, don't be afraid of this. It's not as hard as it looks, because a lot of it is now becoming to be off the shelf, is something you can readily find and utilize. And you should not shy away from reusing these pre-built tools. The second thing is, again, came together with the other line of code from the internet. It was from a GitHub repo of a researcher, and that's just loading a pre-estimated model. this function here, we've pre-built that a little bit for you. The only thing it does is it makes it a little bit easier for you to feed the image into that pre-estimated model, and it returns the output as a data frame so that it's a little bit easier to handle, right? So that's the only thing we kind of had to prepare here, but even that is just to make it a bit more easy to read. So let's test out this new face pointer function and let's see what it returns. Okay, so this is interesting. We have something that has 68 rows, and that number we know, and we've got 2 columns. So 68, if we go back here to our facial landmarks, we know that there are 68 facial landmark points. So that's a very good sign. We got 68 back. And of course, because Python starts counting its index at 0, we have here 67 lines seemingly, but it's 68 because the 0 is also counted. But there's 2 columns. Why is there 2 columns? Because that's essentially the coordinates inside your image. If you remember before, we said there's 3 dimensions. There's 2 coordinates in terms of pixels going up and down and going to the side. And there's the colors. So we just need these 2 to know the exact coordinates of every single one of these facial landmark points. And that's exactly what we have already. So the first 2 points are exactly above each other in this image. So there are 97 pixels from the left-hand side of the image, and 1 point is exactly underneath the other. So 1 point goes down 113 points from the top of the image, and the other point goes down 131 pixels from the top of the image. And also the type, we know that should be a pandas data frame. Let's check that. And yes, it is indeed. And that means one thing we know. It means it's very easy to handle because this is essentially Excel for Python. So I can easily access these columns here using the column names, and I can do very easy operations on this. Another component of what we had seen in the demo before, and that made it really cool if you remember, was we were using the camera. And again, this is something which years ago would have been incredibly hard to do, whereas nowadays it essentially boils down to just having 2 lines of code. So we've got this video capture here, and you can see this is coming from the CV2 library. This is the computer vision library. So now we've set up, just with these 2 lines of code, we set up a connection to the user's camera. And that could be a smartphone camera as well, right? In my case, I'm using a laptop. It's my laptop's camera. It's the same camera we're using here on Teams. And we can then use this connection to grab an image frame from the user's camera. Let's run that. We have stored this now into 2 different objects. One is called ret and one is called frame. Ret in this case stands for return, and it stands for true. So the operation has been successful. We have retrieved successfully an image from the camera, and the frame object is indeed a picture frame. So you can see down here, this is just like the picture that we have seen before. It's very similar. We see here it's got 3 brackets. Again, that's just a normal image RGB format that we have seen before. And we also give you a very handy function, which is, we call it image saver. This function is doing only one thing, is saving the image in the local directory here, right? We do that to make it a bit easier for you. You could also prompt the image to the user directly. We want to show you how to save it as a file as well. So that's an easy way of doing it. You can see here, okay, we're using the RGB coding and we're saving the file inside the local folder under the name yourfile.jpg. And you can choose any other name, of course, if you want that. So let's use that. And let's quickly save that image. We can then actually look at it. It will be in our local folder here. and it's called yourfile.jpg. And that's me holding the course, not very favorably, but it does the job for facial landmark detection. Let's look quickly at the shape, and we would expect, because this is RGB coded, it's 3 dimensionals and there are 3 color images, color dimensions. And indeed, we have the pixels, so there's a 720 times 1280 sized pixel image. And we have the 3 colors, red, green, blue here. And what is also very handy is that this object is in a Numpy format. The key difference between Numpy and Pandas is Pandas data frames tend to work a little bit more like an Excel spreadsheet and are a bit easier, more intuitive for the programmer to handle for us, right? Whereas Numpy is more computationally effective. It is actually a good thing that this image is in Numpy, because then it's easier for and faster for the AI models to use that. So we're actually very happy with that. Otherwise, we could also convert it to Pandas data frame if we wanted to use it, but for this image it's quite unlikely. So Numpy does the trick perfectly. We can do some basic manipulations of this, like with any other data object that you have in Python. So what we're going to do here is we select the first 0 to 200 objects inside this array. So the first 0 to 200 pixels in this case. And then on the second dimension, we select the pixels 90 to 100. And for the color, we don't indicate something. So it's going to select all 3 colors by default. And we set all of these pixels, the value 254. So that, what it really should do is, it should paint 1 line of white pixels. Because we know 254 on all 3 colors should result in a white line. And it's going to be 200 pixels long and 90 pixels wide. So let's save the image frame after we have done this operation. Let's look at the image again. And here we are. There's a big, long, white stripe here, right? So the 200 pixel dimension we were picking is the dimension going down. Now, of course, we can also do a slight rotation. So let's try and actually paint across on side our image. We just need 1 more line for this. So before we were picking the pixels 0 to 200. Now we're gonna have the pixels 95 to 105. So the center of this was 100, which is also the center here. And we have exactly 10 pixels difference. So we're having a width of 10 pixels, which is the same like we had on our initial line. And again, we make it 200 pixels wide. But of course, we have now changed the dimensions here exactly. So let's put that to 255 to make all 3 dimensions again to the maximum value. And of course, we're going to see in the pixel and in the image, there's a big white cross here now. Okay, so that's cool. We can do some simple painting. This technique is surprisingly versatile. You can also just pick a single color channel. So in this case, I want to have everything quite blue. The first color channel here is blue. Be careful, it's inverted to the RGB, how it normally is. And I can set that to 254. We're in this case picking a box of 200 times 200 pixels. And only the blue channel is going to be set to the maximum now. So that is essentially a more transparent way to paint, because the red and the green color channels remain intact. We can kind of see through that blue blocks that we have painted now, but clearly is a lot more blue than the rest of the image. So again, just basic data handling coming together with the images. You can do a lot with this. It opens up all sorts of creativity. Let's put this together with what we've done before. Remember, we're able to get the 68 landmark points with this face pointer function. Let's do that for the image that we have. And then let's look again at the type. Yes, again, is it the Pandas data frame? So that's nice and easy for us to handle. And Pandas data frame means I have very nice indexing for the columns as well. So the name of the first column is 0, and I can pick that. So we have here for the first dimension, we have all the 68 landmark points. Of course, if I wanted to pick only the very first point here, I can then index again. So I'm just saying, okay, from the first column, pick the first element. And because Python starts counting as 0, first actually means I'm putting in a 0. And here I've got the first coordinate of the first point. The same for the second dimension of the picture. So we can pick that here by simply changing that 0 to a 1. And I'm taking the first number here in that coordinate as well. And we're seeing here we have 198 pixels. Then we're doing nothing else like we did before when we were painting these crosses on the image. And the only change we do is we're putting in these coordinates that we retrieved from the facial landmark detection as the center points of the cross. Let's do one cross now. And this is the second line of the first cross. Let's have a look. Did it successfully mark on a facial landmark? And yes, this is the first facial landmark. We've set all the pixel intensities to 254 here. And what we really want to do now, of course, we've got 68 points. We don't want to do this by hand. That being very repetitive, let's put it into a for loop. And now what we're doing is we're simply looping through the index here. So for that, we use the range function, and the range is going to take the values 0 to 68 in rotation. And then we do nothing else like painting that cross again. And this time we're just using that rotation index I. So it's going to go through all the 68 dual coordinates. Let's save the image. And we should have 68 points painted on the face. There we are, successfully. So congratulations at this point. You might already be able to execute this in that case. This is state-of-the-art AI. This is one of the most complex use cases. It should be a huge success. If at any point you're able to do it, maybe even next week you can execute it. In any case, I congratulate you if you're able to do this. It's an amazing learning. It's a huge milestone for you. And we hope that this, together with the new image processing techniques you have learned today, will make a big difference to how creative you can be in your day-to-day work. Let's look at the code so far. And this looks surprisingly short. We had 130 lines of code here, and it really boils down from the point where we had preloaded the model to some 5 lines of code. So we had 2 lines to connect to the camera and to get the facial landmark points. So this has gotten us a fresh image. And then we just do the loop to paint the 68 crosses, and we save the image here. So these few lines of code are essentially all you need with the pre-built work that we had from the internet. That is simply amazing to do state-of-the-art, fresh from the research, cutting-edge AI. Now for one of the use cases we discussed before, that's a liveliness check. Let's take the 62nd point on the height and this the 66th point. So if we look here into the facial landmark points, these are just the upper and lower parts of the lip. And because we start counting as 0, we added 1. So these are these 2 points here. And, oh, sorry, we need to take the 68 points because we need, no, this was correct. Yeah. And then we can simply look at the difference here to see how far the 2 lips are apart from each other. And in the example image, it was 21 pixels. If we see that value changing, we know the mouth must be opening and closing. All right. Thank you so much for dialing in. That concludes our workshop today. Due to the sheer number of participants, which is amazing, it's really amazing to see that. Due to the sheer number, We'll have the interactive elements in a follow-up chat. I'll be available to answer your questions. Simply post them into the meeting chat. You can also reach out to me. You can reach out to your local AI associates. You can reach out to Andy Chun regarding the upskilling. And most of all, feel free to use that. Feel free to make your workday a lot more creative with these techniques. We're really seeing already how people are changing their workday and how these learnings are having a significant impact on how much fun we have and how much fun we're able to have in the office and how much value in the same line we can create for the customers. Thank you very much.
Thank you.